What if I told you that right now, somewhere in the universe, a star is literally tearing itself apart, and in just a few seconds, it releases more energy than our sun will produce in its entire 10 billion year lifetime? Not in a day, not in a year, in seconds. And here's the part that most people never talk about. We can see this destruction happening from billions of light years away, which means we are watching something die that ceased to exist before Earth even formed. Let that sink in for a moment. These events are called gamma-ray bursts, or GRBs, and they are, without any exaggeration, the most violent and luminous explosions ever recorded in the known universe. But what's creating them? That's where science gets genuinely unsettling. Here's the controversy nobody warns you about first. For decades, astronomers were absolutely baffled. They were detecting these intense flashes of gamma radiation coming from random directions in the sky, lasting anywhere from milliseconds to several minutes, and then gone. No warning, no pattern, just a flash of the most energetic light in the universe, and then silence. The scientific community was divided. Some believed they were relatively close events inside our galaxy. Others argued they had to be cosmological, meaning they were coming from the far edges of the observable universe. The debate was so heated it became known as the Great Debate of the 1990s. Then in 1997, everything changed. The Beppo-SAX satellite finally managed to pinpoint the location of a GRB precisely enough for optical telescopes to follow up. What they found confirmed the cosmological hypothesis. These bursts were coming from billions of light years away, which means to be visible from that distance, they had to be incomprehensibly powerful. This moment rewrote our understanding of the universe's extreme physics. Now here is where it gets even more fascinating and a little bit existential. Scientists have now confirmed through multiple lines of evidence that a specific category of GRBs, known as long-duration gamma-ray bursts, lasting more than 2 seconds, are directly linked to the deaths of massive stars. We are talking about stars that are at minimum 20 to 30 times the mass of our own sun. These are not ordinary stellar deaths. These are catastrophic collapses called core collapse supernovae, but with a critical twist. When one of these massive stars runs out of nuclear fuel, the outward pressure that was holding it up against gravity suddenly disappears. In a fraction of a second, we're talking about 200 to 500 milliseconds, the core collapses. And when the collapsing core has enough mass, it doesn't stop at a neutron star. It keeps going. It forms a black hole, right there, almost instantly. But a black hole forming isn't, by itself, what creates the gamma-ray burst. Here's the mechanism that makes this so extraordinary. As the outer layers of the star are still collapsing inward, an accretion disk forms around the newborn black hole, essentially a violent swirling disk of hot, infalling material. Through a process driven by extreme magnetic fields and the rotational energy of the black hole itself, two ultra-relativistic jets are launched outward from the poles of this system. These jets travel at 99.999% the speed of light. When these jets punch through the collapsing stellar envelope and slam into surrounding material, the resulting shock waves produce gamma radiation of almost unimaginable intensity. In 2003, GRB 030329 provided what scientists consider some of the most direct and compelling evidence ever captured linking a long GRB to a core collapse supernova. Spectroscopic data confirmed a supernova, specifically classified as a type ICBL supernova, occurring in direct association with the burst. This connection has since been confirmed in dozens of additional events. And in 2022, one of the brightest gamma-ray bursts ever recorded, designated GRB 221009A, was detected by multiple space observatories simultaneously, including NASA's Fermi and Swift telescopes. Scientists nicknamed it the boat, the brightest of all time. It was so energetic that it literally ionized Earth's upper atmosphere from a distance of approximately 1.9 billion light-years. An explosion almost 2 billion light-years away disturbed our own planet. This is not science fiction. This is documented, published, peer-reviewed science. Now here is the part that should genuinely stop you mid-scroll. Astronomers estimate that long GRBs are occurring somewhere in the observable universe at a rate of roughly 1 per day. 1 per day? We just can't see most of them because they are beamed in specific directions like a cosmic laser, and most are not pointed at us. But statistically, the odds that one could be aimed at Earth from within our galaxy, though extremely rare and estimated at perhaps once every few 100 million years, is not zero. The closest known candidate star for a potential GRB-producing collapse is WR104, a Wolf-Rayet star located approximately 8,000 light-years away. The debate around whether its jet axis is oriented toward Earth remains genuinely open in the scientific community. What we are really talking about here is the universe's most extreme recycling program. Massive stars living fast, dying violently, and in doing so, forging and scattering heavy elements across space. Iron, nickel, cobalt, elements that eventually find their way into planets, into rocks, into you. The stars don't just die quietly. Some of them scream across the entire observable universe, and we are finally learning to listen. If this kind of science makes your brain feel small in the best possible way, follow this page right now, because we are just getting started on the most mind-bending corners of the real universe. So here's the question I want you to answer in the comments. If a gamma ray burst from within our galaxy were aimed directly at Earth today, do you think we would even have enough warning to know it was coming?